Okay, welcome to part 4 of our review packet video. So chapter 6 we started with triangles, law of sines and cosines. So here we don't see a triangle, so we should probably draw it. Now don't try to worry about the scale. I'll just label my angles. A is 41 degrees, B is 72 degrees, and little a, which is always opposite of the big letter, in this case big A, is going to be 15. And we're looking for little c, which is this side length over here. Well, I have a side angle pair, which means I can use the law of sines. But in order to find little c, I need to know the angle c. Well, we know that the three angles add up to 180. So I see angle C is 67 degrees. Now I can use the law of sines. So 15 over the sine of 41 equals C over the sine of 67 degrees. So C times sine of 41 equals 15 times the sine of 67 degrees. So to solve, we divide both sides by the sine of 41. We'll make sure we're in degree mode. We are, good. So 15 times the sine of 67. Now, if you don't close the parentheses, you're going to get the wrong answer. So make sure you close your parentheses. Divided by sine of 41. So C is about 21.05. Okay, 27. Given a triangle with lengths, find B. So little a, 123, opposite of big A. Little c is 86, and angle C is 52 degrees. So it looks like I have an angle side pair. So I can use the law of sines. Now, I'm looking for little b here. So in order to find little b, I'm going to have to figure out angle b. So if I find out angle A, I can use triangle sum property to figure out angle B. So I'm going to first find angle A. So my equation is going to be 86 over the sine of 52 equals 123 over the sine of angle A. So I divide both sides by 86, and that gives me sine of A. Now, normally at this point I'd take the arc sine of A to figure out angle A, but I know sine can never be more than 1. So notice I get an error in the calculator. That means this is not a possible triangle, so there is no solution. Okay, 28, another triangle problem. C is 80.3 degrees, little c 52.7, little b 41.6. Okay, so we're looking for angle B. We have a side angle pair, so we can go ahead and use the law of sines. So 52.7 over the sine of 80.3 degrees equals 41.6 times the sine of B. So we'll divide both sides by 52.7. So I take the arc sine in order to find the angle, and B is about 51.09 degrees. Remember, we don't have to worry about two triangles in this case, and here's why. This is side-side angle, so this is the situation where we might need to worry about two triangles. But notice that this side is bigger than the side over here. So it would be impossible to make two triangles with this. If this was, say, 40, then we might be able to do two triangles. Because since this would be less, we could draw it here or here. We'll do another problem where there's two triangles, though. Okay, given this triangle, find B. Little a is 17, little c is 51, and big C is 100 degrees. And we're looking for little b. So we're going to have to find the big angle there, or the angle measure, which is big B. So let's go ahead and find A first, since we have the side opposite of A. So 51 over the sine of 100 degrees, that's from this side angle pair, equals 17 over the sine of A. So sine of A equals 17 times the sine of 100 degrees over 51. So we'll do the arc sine. So A is about 19.16 degrees. So B, we just take the 180, subtract the 100, and subtract the 19.16. And we get 60.84 degrees. So we solve for B. And we get 45.22. Okay, number 30. Given a triangle with A is 12 degrees, little a is 12, and C is 37, find the two possible values for B. this is normally how I draw the triangle. I'm actually find it easier to put this angle here to the left. So that's 12 degrees. And this is 12. I'm sorry. This is 37. And this side length over here is going to be 12. So the 12 could be like this, or the 12 could be like this. So there's the two possible triangles. So I'm just going to go ahead and redraw the two possible triangles. This is definitely not drawn to scale. Okay, so notice that C could be obtuse or it could be acute. So when I use the law of sines to solve for angle C, using the calculator, you're only going to get one of the two possible answers. So one possible angle for C would be 39.87 degrees. That would be for this triangle here. So to find the other possibility for C, I'll call that C1 and C2, I just take 180 degrees minus the 39.87. So the other possibility for C would be 140.13 degrees. So case 1, C is equal to 39.87. That means B is going to be the obtuse angle. So to find it, I just subtract the two angles I know. So here, B is 128.13 degrees. So I use the law of sines to find B. Okay, so one possibility for B is it's 45.40. Now, for the other possible triangle, we get 27.87 degrees. And we get 26.98. Okay, 31. We have a triangle. We need to find the area. Okay, so for a triangle, we know area is 1/2 base times height. So I need to find a base and a height. Well, look at this triangle here. I could use this as the base, but then I'd need to find the height here. Or I could use the 250 to help me find the height here, and I could find this base. So let's go ahead and find some other sides of the triangle. To do that, we need to find angle C. So C is 65 degrees. So now I could use the law of sines to find the other sides. So notice the side angle pairs, 250 over sine of 65 equals A over the sine of 37. So A is about 136.36. So if I can find this height here, I can find the area of the triangle. Oh, so I see this little triangle here. Notice that if I use the 78 degrees, this is the opposite, and 250 is the hypotenuse. So my height is going to be equal to 250 times the sine of 78. And so my height is about 244.54. Okay, as you were typing along, you probably noticed an error, and I mistyped this in. So this is 136.36. It's actually 166.01. So my apologies. I messed up. Not the first time. So we get 20,298.04 square units. Okay, number 32, we're given 3 side lengths, and we're trying to find the 3 angle measures. So we're going to have to use the law of cosines because we do not have a side angle pair. Now my suggestion is solve for the biggest angle first. And we know that the biggest angle is going to be opposite of the largest side. So in this triangle, the biggest angle is going to be angle C. So we'll use the formula that has C squared on one side of the equation and the cosine of C on the other. So 91 squared equals 78 squared plus 15 squared minus 2 times 78 times 15 times cosine of C. Now, it's important that you don't try to put the right side of the calculator. Because this part over here has a cosine C, so we can't combine those. So instead, we'll go ahead and figure out what 78 squared plus 15 squared is. We get 6,309. Minus 2,340 times cosine C. So we want to get the cosine C by itself. We'll subtract. Okay, then we'll divide both sides by the negative 2,340. So we take the arc cosine to find the angle, and C is 147.43 degrees. So to find A, we can use the law of sines. So 78 over the sine of A equals 91 over the sine of 143.43 degrees. Oh, sorry, 147.43 degrees. Okay, so that's the sine of A. And arc sine gives us the angle. So for B, we can just subtract the two angle measures we know from the sum of all angles in the triangle, 180. And we get 5.09 degrees. Okay, for number 33, I want to find the area. So rather than using 1/2 base times height, since we have all three lengths, we can go ahead and use Heron's area formula. And there it is, where S is the semi-perimeter. So 92 times 92 minus 78 times 92 minus 15 times 92 minus 91. And we get about 314.92 degrees, or 0.92 square units.